Have you ever just looked up and wondered about that? I mean, it's probably one of the very first big questions we ask as kids. It seems so simple, but the answer? Oh, the answer is this incredible story about light, the air, and a little bit of physics. So today, we're going to finally solve it. Why is the sky blue?
Right. This is our big mystery. It's a puzzle that's happening right over our heads every single clear day. And to solve it, we just need to follow a couple of key clues. Our investigation starts with the source of all that beautiful light.
So, clue number one has everything to do with the sun itself. Because, you see, the light it sends our way isn't exactly what it looks like. When we look at sunlight, our eyes just see, well, they see bright, right? It looks like one, single, powerful, whitish, yellowish light. But that's actually just a really clever disguise. Here's the secret. Sunlight isn't just one color at all. It's actually a super team of colors, all bundled up and traveling together. You know how a prism can split white light into a gorgeous rainbow? Well, that's what's hiding inside every single sunbeam. And here's the whole crew. Every color you can think of, from red all the way down to violet, all packed together, moving as one. Now, you gotta remember this team of colors, because the way they each behave is the absolute key to this whole thing. So let's check out the second part of our mystery, the place where all the action happens.
Okay, so we've got our light, which is really a rainbow of colors. Now we need the stage for our story, and that is Earth's atmosphere.
Before that sunlight can actually get to your eyes down on the ground, it has to make one last, really important trip. It has to punch its way through this invisible shield that's wrapped all around our planet.
And this blanket isn't empty. Not at all. It's actually a thick, bustling soup of tiny little gas molecules. We're talking mostly nitrogen and oxygen. So think of it like a giant, invisible obstacle course for those incoming sunbeams.
So we've got our main characters, the rainbow sunlight and the atmospheric obstacle course. The entire secret to why the sky is blue is what happens when these two finally meet.
And this is the most important part. Those little gas molecules in the air, they're kind of like picky bouncers at a club. They interact with some colors of light way more than they do with others.
And this lays it all out perfectly. You see, blue light travels in these short, choppy little waves. That makes it the perfect size to bump into all those tiny air molecules and just get scattered everywhere, like a pinball, bouncing around like crazy. But red light, with its long, lazy, stretched out waves, it's much more likely to just cruise right on by those molecules without much trouble.
And there you have it. That's the answer. The sky isn't actually a big blue dome above us. It's our atmosphere, completely filled with sunlight, and the blue part of that light has been bounced and scattered in every possible direction for our eyes to see.
So let's just run through it one last time, real quick. The sun's full rainbow of light hits our atmosphere. The tiny gas molecules grab that short, choppy blue light and just throw it all over the place. So no matter where you look up, some of that scattered blue light is heading right for your eyes. So simple and so cool.
But hang on a second. If the sky is blue because blue light gets scattered so easily, that brings up a whole new question. What about when the sky isn't blue?
Exactly. If our atmosphere is so great at scattering blue light, where does all of it go when the sun goes down? Well, it turns out the very same science that explains our beautiful blue sky also gives us the answer for a fiery red sunset.
See, when the sun is right up over your head, its light is taking the shortest possible route to get to you. It's only traveling through a pretty thin slice of the atmosphere, which means there's plenty of blue light to scatter down for you to see. Now, check this out. As the sun sinks down to the horizon, its light isn't coming from straight above anymore. It's coming at you from a low angle, and that forces it to travel through a much, much thicker chunk of the atmosphere to get to you. And on that much longer journey, pretty much all of that delicate blue light gets scattered away from your line of sight before it even has a chance to reach you. So, what's left? What makes it through? Only the tougher, longer wavelengths, the reds, the oranges, the yellows. They're the ones that survive the long trip and travel in a straight line to our eyes, painting the sky with those amazing colors.
So it all just comes down to this. A blue sky is the light that gets scattered, and a red sunset is the light that survives the journey without getting scattered. It's the exact same science, just viewed at a different time of day. How cool is that?
And that leaves us with one final thing to think about. The color of our sky is all about our specific atmosphere. So, what about other planets? Mars, for example, has a really, really thin atmosphere, mostly made of carbon dioxide. So based on everything we just learned about scattering light, what color do you think the sky is on Mars during the day, or even during one of its sunsets? That's a fun one to chew on the next time you're looking up.